Welcome to the most misunderstood chapter of mathematics, or can I say probability. This is the most misunderstood. No matter how many times you study this, you always get confused because you learn probability from your 8th standard if you're in CBSE, and you start off in the 9th standard if you're in ICSE. Okay, so what do you learn? You learn the same chapter in different ways. And that's exactly why this is difficult, because initially when you learn probability, you would learn it as a number by a number, some number on the numerator and then some number in the denominator. That's how you started learning probability. But when you keep graduating to the next class, or you go to the next standard, you learn the same probability in a different way. Okay, what do you learn and how exactly it is different, we will look through that in this video. And now when you are in 11th of CBSE and 12th of ISE, okay, you learn the same chapter in a different way altogether. This is not only the most misunderstood chapter, it is also the most difficult chapter. Okay, it is difficult, I should accept that. Why? Because it has another ingredient in it: permutation combination. Yes, permutations and combinations. You have to be good at permutation combinations to really understand probability. Well, if you're not good at permutation combination, that's alright, because as and when I'm doing questions, I will try to explain to you the concepts from permutation combination. You also need to know sets. Okay, the concept behind sets. Now, permutation combination, along with sets, along with probability, is a very good combination, right? And yes, it is a far more difficult chapter than any other chapters, because it involves a lot of logical thinking. Okay, I'm sure that you would have faced a lot of trouble when you're doing permutation combinations. I can tell you one thing: I've seen questions which is being solved in one textbook. Okay, the answer in that particular textbook is different, whereas the same question in a different textbook altogether, okay, the solution and the way of solving is being completely different. Okay, and this I'm telling you over the period of time, like 6 years I've been teaching permutation combination and probability, and yes, there has been a trouble with that. Now you take up this chapter and put it to a chapter which I've been learning over the period of time in 8th and 9th and 11th, and you've been learning all these things in a different way altogether. Because initially when you learn probability, you would have said, oh, probability is very easy for me, there's nothing to do. All I have to do is divide this number by divide that number and I get marks, right? That's what you did. But now that's going to change, okay? Keeping that in my mind, what we're going to do is to understand probability. Basically, when and how was probability founded, or why exactly was there a need for this particular chapter, probability? It was when a game of gambling was played, that there was a need for a certain situation to be solved. I'm not going to get into those things, okay, because we're not here to understand what it is, why was it taken birth and all those stuff, because that itself is very interesting. I would request you to go back to your textbooks and read this. You can read the CBSE 11th R.D. Sharma. There is a good explanation about the history. Otherwise, I would suggest let's see. I didn't find any good book, talking about the history. What I referred to was S.C. Gupta. Okay, S.C. Gupta and V.K. Kapoor. People who are into statistics, okay, they would know about this book, S.C. Gupta and V.K. Kapoor. It's like a big book. It's one book for referring to statistics. Otherwise, you can just go online and Google it out. It's a very good option. You can just Google out the history behind probability, and you will know that it was, found during the game of gambling. There was a situation which was supposed to be solved, and they took it to the mathematicians, and yes, that was the biggest mistake they did. Why? Because if you go to a mathematician with a problem, the first thing that he's going to do is to add a new chapter to the textbook. And that's exactly what they did, right? And now we have a new chapter that's been added to our textbook, and yes, that's the most difficult chapter. Okay, but with a proper understanding of this chapter, it's not going to be that difficult. It's going to be very, very simple. The concept behind probability is so easy. Okay, it's just logical. Okay, great. So initially it was founded with gambling, and then the application of it was pretty wide. Right now, the probability is extensively used in the field of physical sciences, commerce, biological sciences, medical sciences, weather reporting, and etc. There's many more applications of probability and statistics overall. Okay, so let's give it a kick start. Okay, let's understand probability and get ourselves acquainted with the latest way of learning probability. Okay, great. Before we can understand probability and different theorems in probability, what we're going to do is to understand few terms and terminologies like the definitions. Okay, we're going to understand this. On basis of this, we're going to learn probability. Okay, the first thing that we need to know is what is an experiment. An experiment. Okay, what is an experiment? Anything that I'm doing is an experiment. Okay, you watching this video is an experiment. You talking to your friends is an experiment. Anything that you do is just an experiment. Now there's two types of experiments. Okay, the first one is the deterministic experiment, and then the second one is the random experiment. This is going to be a bit lengthy video. I would advise, and I'm sure you would have already seen the timer on the video, I would advise to be patient and go through this video once. Okay, when you go through this video once, it will be really easy for you to understand probability later. So there is a deterministic experiment, and then there is a random experiment. We are going to be focusing upon random experiment. Let's understand what is a deterministic experiment. When I say deterministic experiment, I mean experiment where the outcome is known to us. Let's say, for example, I take a stone. Let's say this is a stone I took in my hand, and I'm going to throw it really hard at a person. And I'm sure that this person is going to get angry. Well, it does hurt him, so that's a deterministic experiment for me. I don't need to do that to check if he's going to get angry or not. Okay, another example could be, let's take a glass of water, and this is the water. Okay, now what I'm going to do is I'm going to flip it. Now when I flip it, I for sure know that water is going to fall out or fall down to the ground, isn't it? So this is a deterministic experiment. Why does this happen? This happens because of gravity, isn't it? The gravity is going to pull down the water to the floor. Right? Now again, that's a deterministic experiment. I know that this is going to happen for sure, and I'm not going to be interested in that because I already know what is going to happen. What I'm going to be interested in is something that I do not know how and when it's going to happen. So I'm going to predict that. Based on that prediction, I can take my decisions, and that's exactly why we are interested in random experiment. Okay, so an experiment where the outcome is unknown or not known is a random experiment. Now that alone does not make it a random experiment. Okay, let me explain that with an example. Let's say there's this person, okay, he's walking on the road, alright, and it is the path he's taking. Okay, so he's just walking on the road, don't know why, maybe he just wanted to walk. Alright, now what he has in his hand is a ball, let's say a cricket ball, and he's just walking. Alright, now is this a random experiment for me? I do not know what he's going to do, but is it a random experiment? Let's see. Well, what are the possible options? 1, he can do nothing. 2, throw the ball. 3, juggle the ball. 4, dribble it. You just keep tapping on the floor, tapping on the road, and well, if there is a vehicle coming in front of him, let's say there's a cycle or a scooter coming right in front of him, then there's a person driving the vehicle. Okay, he might just throw. He looks like a dog though. This looks like a dog. Okay, though he might just throw the ball at him, right? Or he might just hit him, or whatever that is. So there are many more options. Or he might just cut the ball open. So there are many more options. I don't know what he's going to do. Correct? Now this is not a random experiment for me. Okay, so here I'm going to tell you the second condition for an experiment to be a random experiment. The first condition is that the outcome is not known. However, I know all the possible options. I know all possible options or all possible outcomes. We will have to go back to rolling a die question or rolling a die example. Rolling a die. Okay, now I know what's a die, right? This is a die. Okay, I'm going to draw the die. Okay, there's, let's say, the 6 here, and 2, probably 3. I don't think so. There's 1, 6. I think this will be fine. Okay, so what are the possible options I have? 1, 2, 3, 4, 5, and 6. Those are the possible options, isn't it? But do I know what happens when I throw a particular die? I do not. But do I know all the possible options? Yes, I do. So this is a random experiment for me. Getting it? Okay? So that's the difference between a deterministic experiment and a random experiment. Okay? Very nice explanation. Now, let's move on. Frankly telling you, I have like multiple textbooks opened here right in front of me. I have textbooks from, I think this is 10th CBSE, SC Gupta, R.S. Agarwal. I have the ISC textbook open. I have the R.D. Sharma open. I have textbook from 8th standard open. And I have my own notes made on probability. Okay, because I have collated all the data and made notes for myself because I tend to teach in detail. Okay, so in my notes I have updated the set of all triangles on a plane, right? No matter what triangle that is, we already know that the sum of all the angles in a triangle is going to be a 180. So this is not a random experiment for me. Finding the sum of all the angles in a triangle is a deterministic experiment. Okay? Okay, now what we're going to do is to understand few words here. Okay, words are a trial, an event, a sample space, and mutually exclusive events. Mutually exclusive events and exhaustive events, and impossible event, and then a sure event. Okay, and let's see, is there anything else? Sure event, sample space, elementary events. Write that here. And a compound event. I'm going to write that here itself because this is a 8 and this is going to be a 9. Compound event. We want all these things to be on one slide. Okay, now I'm going to explain these one after the other. I'm going to come back to this space and keep taking it out. Okay? Alright. Alright, now let's say, I'm throwing a die. So the random experiment is throwing a die. Okay, so what are the possible options? 1, 2, 3, 4, 5, 6. All the possible options of a random experiment written in a set form is this sample space. Okay, so what have I explained? the sample space. So what is it? It is all the possible options of a random experiment, all the total possibilities of a random experiment. So I'm going to click that out here. That is my sample space. Done. Okay, now let's go back. So this is a set by itself, isn't it? So I can have many subsets to it, right? So let's say, for example, I had a set A as a 1, 2, and a 3. So what are the possible subsets? I can have a 1, I can have a 2, 3. I'm going to write this for you. Okay, so those are the possible options. Let's see how many do I have. 1, 2, 3, 4, 5, 6, 7, and 8. 8 possible options. So if I have a set with 3 elements, the total possible subsets are going to be 2 to the power of 3, which is 8. So in that case, I'll have 2 to the power of 6 subsets to this, which is 64. Okay, so I'm going to have 64 subsets to this. I'm not going to write all of them, but here I'm now going to define an event. An event is a subset of a sample space. So how many sample space, how many events can I have for this particular sample space or the random experiment itself? I can have 64 events that I can define here. So an event A can be defined as getting an even number. Okay, now what are the elements belonging to this? 2, 4, and a 6. That is all it is. So an event is a subset of a sample space. Okay, so now let's go ahead. So I got 2, 4, and a 6 as the events or the elements belonging to this particular sample space. Now I can also define an event as let's say B as getting a 1. Just getting a 1 as an event. Okay, now what happens here? The possible options is going to be just the 1. This is my elementary event. What is an elementary event? It is an event where the number of outcomes is just a 1. Okay, it's a subset with 1 element, which is a singleton set. If I'm talking about this in terms of sets, it's a singleton set, and here it is not a singleton set. But this is a compound event. Okay, what is a compound event? An event which is not elementary event. Basically, it has more than 1 outcomes. Okay, that's a compound event for me. Alright, now let's move on. I'm now going to define another event. Let's say C is going to be equal to getting a odd number, getting an odd number. Okay, and C is going to have 1, 3, and a 5. Now I'm going to define another event. Let's say D, which is getting a 4 and or, I cannot use an and here, 4 or 6. So the elements belonging to this is going to be 4 and a 6. And now I'm going to define another event. All these are connected. They're going to be used. Okay, I'm going to be using another event. E is getting a prime number. Getting a prime number. And E is going to have what? 2, 3, and a 5. Okay, now let's look at the event of getting even numbers. Okay, which was let's take that here, A as 2, 4, and a 6. 2, 4, and a 6. Now what is C intersection D? Here, C intersection D. Nothing, right? So C intersection D is a null set. So this in sets is defined as mutually exclusive sets. The same thing in probability is defined as mutually exclusive events. So C and D are mutually exclusive events. Okay, basically when I throw the die, I cannot have C and a D happening at the same time. What do I mean? Let's take an example here. Again, I'm going to consider the same thing. Let's take E and A. When I throw the die, there is a possibility that I can get a 2. Now 2 is a prime number and also an even number, so it's appearing both the sets. So when I throw the die, there is a possibility that both E and A can occur at the same time, which is getting a 2. And hence this is not mutually exclusive. Okay, the same concept in sets has been explained in probability in terms of events. Alright, now let's understand what is an exhaustive event. Let's take event C, event E, and event D. Okay, so what are the events under consideration? Event C, event E, and event D. What is the union of this? So basically I'm finding the union of C with the union of D. Okay, will that not give me 1, 2, 3, 4, 5, 6? It gives me all the elements belonging to the sample space, which means it is a sample space. So this sets, all three put together, are called as exhaustive events. Okay, so here we have understood the mutually exclusive events and we have also understood the exhaustive events. Now, is there a possibility that I can have 2 or more events which are mutually exclusive, and exhaustive? Both mutually exclusive and exhaustive. Yes, it is possible. Consider this event, getting an odd number and getting an even number. These two. Okay, I'm going to use a different pen to show that to you. This. Okay, that's a different ink. That's a different ink. So these two events are both mutually exclusive because the intersection is a null set. Not only that, they are also exhaustive because the union is giving me a sample space. Okay, so let's go back and check this. So I have explained to you what is an event, right? I have explained to you what is an event. All right. Now I've also explained to you what are mutually exclusive events, exhaustive events, and I've explained to you what are compound events and what are elementary events. So what is left out? Sure event, impossible event, and a trial. Let's look at that. I explained event as a subset of a sample space, isn't it? Now if I looked at the number of subsets I had here, I had 8. I had 8 sample space subsets, isn't it? Correct? Now along with that, the set itself was a subset. Correct? The set itself was a subset and a null set. Okay, now let's understand this with respect to probability. I'm now going to define another event. I know I'm defining a lot of events, but bear with me. I'm going to define an event M, let's say that is getting a number less than 7. Well, that's going to happen for sure, isn't it? Whenever I throw the die, I'm sure to get a number less than 7. There cannot be a number more than 7, that's for sure. So M is basically going to have 1, 2, 3, 4, 5, and 6. Basically, which means that this is the sample space for M. And that is why this is called as a sure event. It's sure to happen. Now, another event, let's say I'm defining another event, let's say N, which is getting 7. Is that going to happen? It's not going to happen. So this is a null set. And exactly why this is called as an impossible event. So in a trial, I can never get a 7. I use a new word, trial. What is a trial? Let's say I'm throwing the die, all right? The action of throwing the die is a trial. Okay, that action of throwing the die is the trial. Now, in a particular trial, I can get any number. That result of the trial is the outcome. It might be throwing the die, tossing the coin, flipping a card, no matter what that is. So trial is performing of the experiment, just the action, and the result of the trial is the outcome. Now, based on the outcome, I can either say that event has occurred or not occurred. So if I'm talking about A being an event of getting even numbers, if I've got a 2, then I will say in that particular trial, event A has occurred. Otherwise, event A has not occurred. Okay, so that's the trial for me. Impossible event and sure event. Let's go tick that out. So I have understood what is a sure event, what is a sure event, what is a trial, and what's an impossible event. So that's the words that I have understood, or the concepts that I have understood. Okay, so let's understand something more about probability. So when you actually started learning probability, you learned mathematical or otherwise called as classical or otherwise called as the priori probability. A priori probability. Okay, this is what you learned. Now, what did you learn in that? You learned number by number. That's exactly what you learned. Number of, in that case, you found the probability of an event as favorable cases. Favorable divided by number of cases, or total, right? That's what you did. So throwing a die, getting an even number is, favorable cases. You in this mathematical approach or classical approach, you actually had to perform the experiment. Getting me? So you had to manually perform the experiment and then identify your probability. So for example, if I've thrown the die 10 times, out of 10 times, how many times did even numbers occur? I don't know, might be 2 times or 10 times or 5 times or 6 times, so whatever that is, so 6 by 10. That would have been my probability in mathematical, classical, or a priori approach. So when I'm even tossing the coin, so if I'm tossing the coin, let's say for 20 times, and then out of 20 times, I got head only for 5 times. So 5 by 20 would have been my probability. Obviously, they had a problem with this because you had to perform the experiment. So you had to wait for the experiment to be performed before you can actually get any result, isn't it? Now, without even performing the experiment, you cannot find probability. What's the use of it, right? I mean, if something has already happened and then you do post-mortem on that, I don't know how useful that is. But think about a situation where you can actually predict what's going to happen and then change your actions accordingly. That's going to be more useful for me. And exactly why this had a limitation. And that is the limitation it had. That you had to actually perform the experiment, and the events are not equally likely. Now, this is a very important word. I'm going to explain this to you. Equally likely. Okay. So, say for example, the event is going on and on and on, and it's never going to end. How do I find the probability to it, right? I do not know, because for me, I have to find the total. So that was the issue with the mathematical or classical or a priori approach. And then they modified learning probability, which is what you learned later on. You learned the empirical method, or called as the statistical method. Statistical method of probability, or statistical probability, right? Now, it's otherwise called as a statistical approach. What did you do in this? It's also called as the theoretical approach. I'm covering the words from different textbooks so that you can relate to this, okay? Because you learn the theoretical approach in some textbook and statistical approach in some textbook. It means the same thing, but you learn it in a different way. I mean, you learn different words for the same thing. So what did you do in this? You didn't actually wait for the experiment to be performed. You analyzed it, right? What did you do? Let's say, for example, throwing the die. Okay, you're not going to actually perform the experiment. You're going to sit and think, okay, what are the possible options? 2, 4, and a 6. What are the total options? 6. So the probability would be 3 by 6, which is 1 by 2. Okay, so in this case, what did you do? The probability of an event will be favorable events divided by exhaustive events or elementary events, total elementary events. What are the total elementary events in this? 6. Getting a 1, getting a 2, getting a 3, getting a 4, getting a 5, getting a 6. 6 elementary events divided by 6, and the favorable events, which is 2, 4, and a 6. That would have been your probability in empirical or statistical approach. Okay. Well, this also had its own limitations. Let me say what. Let's say, okay, let me ask you a question. What is the probability of raining tomorrow? Rain. Is it going to rain tomorrow? What's the chance of raining tomorrow? So you will say 2 options, which is rain and no rain, and favorable is rain. So 1 by 2, right? I didn't do anything. I just did the probability, right? So would you be able to make the same statement in a desert? So you went to Thar Desert. Okay, and you say to a person in Thar Desert that, you know what, don't worry, tomorrow it's going to rain. You're going to look so stupid, isn't it? And there was this limitation of this particular approach, right? That, you know, again, there is not equally likely events, and you had to again think about the way to approach this particular probability or this probability. So with that being the limitations, I also, you know, for classical approach, I have a very good example. Let's say you're running a factory, and you manufacture matchboxes. Okay, let's say this is the matchbox that you're manufacturing. Home lights. Yeah. No, I cannot use a company's name. I'm going to just use something. I don't know what that is. Okay, so that's a matchstick you're manufacturing, and you want to identify the probability of it not lighting. When you light the matchbox, what is the probability that the matchstick will not light? So what you do is you call a person and you say, you know what, I want to do this probability. Can you approach in the mathematical or the classical, you know, method, and then perform the probability for me? So he will say, yes, ma'am, I'm going to do that for you. And he's going to work the entire night. And tomorrow morning, when you go back to the factory, he's going to say, you know what, you have a very good probability. This is the probability of failure, which is very, very low. And hence, you're going to be happy, isn't it? Well, you should be happy for the probability being so low. That's the probability of failure being so low. However, he would have lit all the matchstick for you. The entire night he would have lit the matchstick and then found out the probability. And that's another problem with the mathematical or classical approach. Okay? And again, if he is applying the same thought process for empirical approach, he's going to say, okay, so what are the 2 options? Matchstick is going to light and not light. 2 options. Out of which, how many times is it not going to light? 1 time. Getting me, favorable outcome is not lighting, 1. So 50%. So now he's going to say 50% of your matchsticks is not going to light. Well, that is again, you understand what I'm trying to say, right? So that's again another problem with this empirical approach or the statistical approach or the theoretical approach. So that's when they said, you know what, we're going to approach or learn probability in a new way altogether, which is the axiomatic approach. Okay? In the axiomatic approach, we're going to learn probability by defining 3 axioms. Okay? And we're going to learn the 3 conditions for axiomatic approach of probability in the next video. Because in this video, I have explained the basics of probability and the different types of probability, the different situations or the approaches to probability. So in the next video, we will pick up more information on axiomatic approach, which is completely dedicated to axiomatic approach. Okay, I would want you to again be thorough with these concepts before we can actually go ahead and do those questions or understand more about axiomatic approach. Okay, and Please do not forget to subscribe to these videos. Ask your friends to go through these videos. These are very informative. Go through these videos. Ask your friends to watch the video, subscribe to it. Thank you.